Huh? It has? Thank you. Thank you for finding it. Sorry that WebAssign is so perfect. It's like the worst program I've ever used. Sorry for all the noises. Alrighty. So set up your, we know that the volume is equal to pi r squared times h, correct? So therefore, dy is going to be in there. And you've got to figure out the r. So we can go 1, the volume of the slice is equal to pi r squared h. And we'll go down here and we'll set up 0.5 is to 4 as r is to h. And that's going to be 0.5 is to r, 0.5 is to r as 4 is to h. So 4r is equal to 0.5 h. Divide by 0.5 or divide by 4. And what do you get? I'm sorry, what? 0.125. 0.125. So r is equal to 0.125 h. Is that what y'all got? So that's going to be, so I'm going to do 2 right here. And then 3 is going to be v of the slice is equal to pi times 0.125 h times delta h. So there's your volume of your slice. Now, thanks to Miss Anthony and her wisdom.
Yes, square.
Thank you. I can hopefully work this and make it smaller.
What'd you do?
I thought I hit group. Okay, and of course, what does it do? It hides the little.
You can reach the one at the top.
Oh, I can reach the one at the top. You want to try that again?
You can, you just gotta work for it.
I know. It's my fault. Of course, this is operator error, isn't it?
Yeah.
Just disappears. What happens to it?
You don't have to drag it all the way off now. You can just like drag it a little bit. There you go. See?
Thank you, Miss. forget it. Go to the next freaking page. V of the slice is equal to pi times, I done forgot, 0.125 h quantity squared times delta h. And somebody go ahead and 0.125 square it so I can go ahead and pull it out. What does it come out to be?
64.
I'm sorry, what? 0.125 squared comes out to be what?
1.8. 0.016.
Thank you. 0.16 pi h squared dh. Okay, there's your volume. Now what? What is the mass? So go ahead and do that. Volume times the density, which the density is going to be 9. Might as well go ahead and throw 9,800 in there. So I'm just going to go ahead and throw it in there. So volume times density is mass. Mass of the slice is equal to, I'm going to go ahead and throw 9,800 in there, times 0.016 pi times h squared dh. And then multiply that by what? The height, the distance, which is going to be 4 minus h. Throw that in there. And that's the force of the slice is equal to the mass times the distance. So 9,800.016 pi. Okay, we're making designs with our pen now. Pi h squared times, what did I say, 4 minus h? dh. Now, since we are working with 4, since it is full, what is your parameters going to be? And then you're finding the volume of the water, technically, is 0 to 4. So, work is equal to 9,800, I'm thinking, 0.016 pi integration 0 to 4 of 4h squared minus h cubed dh. And that's going to be equal to 9,800.016 pi, and then brackets 4h cubed over 3 minus h to the 4th over 4 evaluated at 4. I'll do 0 for you. 0 comes out to be 0. So that's equal to 9,800 times 0.016 pi. And then that's going to be 4 cubed over 3 minus 4 to the 4th, whatever that's supposed to be. 4 to the 4th over 4. What's 9,800 times 0.016? Calculator drill team, let's go. How much?
156.
Okay, I got somebody said 153, and somebody said 156.
Because I use one decimal.
All right, let's go with 156, if that's okay. 156 pi times, and somebody crank this out to a number, please. I'm sorry. Did everybody get 23?
21.3, yeah.
I asked, did everybody get 23? 21! Make sure when y'all design bridges, please put plaque on the front to say, so-and-so built this bridge so I can read it before I go over the bridge.
Oh, you'll know. You'll know.
Yeah, that's right. There'll already be paramedics there, right? Okay, is it 21 or 23?
It's 21.3.
Okay, 21. And then 21 times 156, what do you get?
33.28.
And that's what it comes out to be, 33. Around, with y'all's calculations, 33, what, 23? 28 pi. And what will that be? What units? Joules. Now, figure out half. There should be only one difference. And what is that? 0 to 2. Somebody take 9,800 and divide it by 3 for me.
32.67.
30 what?
32.67.
Okay, we're a little bit off because they used fractions, but that's fine. We use decimals, they use fractions. The setup is still going to be the same. So 0 to 2, we'll do that. I have to write everything because I'm giving up on trying to be innovative with this system since I've had so much training. Work is equal to 0 to 2 of 9,800 pi times h squared times 4 minus h dh. Is that everything in there? Make sure I haven't left anything out. I'm going from memory. 9,800 pi 0 to 2 h squared 4 minus h dh. 9,800, and that's going to be 4h to the third over 3 minus h to the fourth over 4, evaluated at 0 and 2. The 9,800 pi times 8 times 4, what does that come out to be? 8 times 4 is 32 thirds. Minus 2 to the fourth is going to be 16 over 4, which is 4. Well, 16 over 4. Somebody work that out right quick. What do you get? So I'll have the inside. It's 9,800 pi times what? That don't seem right because we're coming out with more work. Make sure I haven't left anything out, please.
Your fraction or decimal from
Yeah,
radius.
that's it. How much is that?
0.016.
0.016. I knew I left something out. Okay, so 0.016.
6 2/3 is
Right here, how much?
6 2/3.
6.67. All right, crank that out. Give it to me in terms of pi.
1,026
That gum, Miss Anthony's on that dadgum calculator drill team. All right. So is it half? How much was it work on the other one? 3,000? And to pump half out, 1,000. So it's not exactly half.
They was asking if half the work was half the volume they're doing.
Said, is it true, let's looking for a true false, that it takes half as much work to pump the water out when it's half full? It's not true. And the answer is not true. So y'all used a little bit of critical thinking there, so give yourself a pat on the back. Y'all still suck. All right, you ready? Trough. Now, for those of you that don't know what a trough is, it's what you feed cows and pigs in. All right? No, I'm just kidding. It can be used as a swale also. You know what a swale is? It's your parents' fault. A swale is a depression that you can make in a curb and gutter system. Some of y'all have gone over a curb and gutter before. A swale is I'm trying to draw this, okay? It wouldn't be nice if the freaking board would cooperate. Okay, I'm exaggerating a little bit. But that's a swale. Now, I'm exaggerating, but basically your water comes what? Down through here. Okay? And of course it goes on. A swale is a depression that you make that is not a ditch. Here's a ditch. Okay, there's a ditch. Okay? Yeah, that's what y'all gonna live in right here. There's a ditch. All right, now, if you drive a car cannot go over a ditch, okay? End up in the ditch. But a car can go over a swale because what? It's not, in other words, this is a ditch. A swale looks like this. Okay? That's a swale. Okay? Use them in curb and gutter. Some of you have been to Zaxby's down here on 28? Okay, y'all suck. All right, well, when you pull out of Zaxby's, curb and gutter, for those of you who don't know what curb and gutter is, this is a curb. Okay, and then you got your road right here, crown of the road, drains off into the curb, and then goes down the curb, and then you step up onto this curb right here, about 6 to 8 inches right here. That's a curb. But a curb and gutter looks like this. There's your road, crown of the road, and then it drains down. So why do you have curb and gutter versus curb? You can drive across it. It's a little bit rougher, but this is curb and gutter. The only thing different is your apron. Apron is a asphalt apron. I don't know how to spell asphalt. There's LPT in there somewhere. Anyway, and there's the road, okay? There's the difference, all right? There's an asphalt apron. You drive right onto the road. Curb and gutter, you drive onto it like that. Okay? And this, you don't drive off of this unless you just want to tear up your front end. Now, why do you have the 3 different types? Well, for your drain off, for a lot of water drain off, you have to use this. For medium water drain off, you use this. And for hardly any water drain off, you use this because the road is not affected. Right here, the road is not affected. In other words, you don't have a lot of water drain off. Okay? Now, the swale is why you would use a trough. Basically, a swale is a trough. Here's a trough. Dang old. I don't like that. Hold on. Let me start over. We used to make these all the time on the farm. Take 2 1x6s. And that's a trough, especially pig troughs. Take 2 1x6s, put them together, nail them together, and then put 2 1x6s right there, and you got a trough. Okay? But a trough is basically a swale. Like that, except I can't draw, so. But you can't see it hardly because it's so shallow. All right, but there's your basic. See it? Okay. Of course, the swale is a whole lot more. It's kind of like parabolas. Remember your parabola? Well, there's your algebra parabola right there. And you said, when in the heck are we ever going to use that? Well, what is this? I can't draw this crap. A dang old satellite dish. That's what it's supposed to be. Satellite dish is nothing but a shallowed out what? Parabola. A swale is nothing but a shallowed out trough. Okay? So that's where a lot of you that's going into civil engineering and hydrology are going to be studying this kind of stuff. All right, so here we go. So there's your trough, and it's 3 meters high. No, 3 foot. Thank God. 3 foot. It's not to scale, so don't laugh at my. Of course, it's 3 foot. I'll just do this. I'll erase that. Trying to make it a little bit more 3 foot on top. 3 foot up here. And 10 foot long. And it's full of water. Water at 62.5. Pump it out. Full of water. Now, the only thing I want you to do different is this. Remember? There's your slither. But it also goes what? This way. So remember, this is actually what is that? Okay. It's a rectangle. Volume of a rectangle is length times width times what? Oh, I'll do the length for you. Now, I did the length for you. You just find the width. Why is that a problem? The width is 3. No, it ain't. You just failed hydrology and civil engineering. You should go work at McDonald's and live in a ditch. Why is the width a problem? Changes. Good job. Now you do it a little bit differently because you got to use the 3 minus h as the height of your smaller triangle. And that's because this is a trough, and it's a little bit different from a cone, a little bit. A cone is circular, a trough is not circular.
Can you not use like similar rectangles?
Yeah, similar triangles. You got to use similar triangles. Whoever asked that. Will you quit trying to be difficult and just do the problem?
No, I was like asking if you could
No, it'll blow up. Actually, you can't, because if you use similar rectangles, the rectangles are changing also. So it'd be easier just to do the triangle, because the triangle is more of a related rate. Dadgum, you are back there. You awful quiet this morning. You sick? You hanging in there? Well, you know what to do whenever the tough gets going. What do you do? No. Starts with a Q. Quit. One of my students, I tell her, she's on my Facebook all the time. Some of you may know her. I'm not going to mention her name, but anyway, she's in physics. She's going to be a physicist, and she went to Westside, and yeah, she's sick. She's sick in the head. Anyway, she is like in her junior year at Clemson in physics. She's doing real well. She was in my Calc 1, 2, and 3. That's when we were able to teach Calc 3 here, but we can't teach it here anymore because I have to teach it at Pendleton campus. And when you go to that Pendleton campus, you better tell them that you had in-class tests in my class, and they were hard and just very, very difficult to pass. Good luck. I don't want to teach up there. I hate going to Pendleton campus. Huh? I wouldn't teach it for y'all, no. I think y'all need to be inducted into the Anser Hall of Fame of calculus. Oh, you're just going to quit, huh?
Calculus 2 is good enough.
Yeah.
Can you teach it?
What's your major? You get calculus, what's your major?
I'm going for software engineering.
Yeah, so you don't need all that other stuff. You have to have up in any physics?
I just need to have a bunch of sciences, so
Yeah.
we eventually get to physics 1 and 2.
I think there's some weird math courses like that. Discrete mathematics, I know, but
Yeah. Y'all have to study the dang old hexadecimal system and the different decimal systems where in a hexadecimal, like hex 8, 0 plus 8 is, or 1 plus 8 is 0. Or hex 9. Yeah, there you go.
good little pocket right.
Did y'all see The Martian?
Yes.
It's good. He used a hexadecimal system.
Which one is it you're going to give us?
I don't know. I don't repeat myself. 13 hours. How many civil engineers are in here? Oh yeah, you're doomed. You got to take Calc 1, 2, and 3, Physics 1, 2, and 3. Yeah, you're doomed. What I did, I took Physics 1, 2, and 3, Calc 1, 2, and 3, FAQ, Statics, Dynamics, Thermodynamics, and then I decided to go to math. Huh? Hey, I taught it. I taught 2 semesters of it. You have to talk to my boss. All right. Now, why is this 3 minus 8? Well, because this distance right here, just like before, is 3 minus h right here. There's your 3. And then h is right here. So it's kind of like we were doing with the conic, except the conic, we use that as a distance. And we're going to use it again not again, but we will use it with the integration, and it'll make its way into the integration. Just take my word for it, because it's in the conic. We didn't have a rectangle. Everybody with me? Okay, so the 3 minus h had to be integrated at a different time with the conic. This is not a conic. It looks like a conic, but it's not. And the 3 minus h is incorporated into the height. It's already in there. You see what I'm saying? Just think of the two problems as different. They are different because this is not a conic. And that's all I can tell you. Do you remember when I told you that whenever you use metrics to use 9.8? And y'all said, but why? But why? And then everybody got confused. Okay, do we want to go through that again? Everybody says no. Everybody's supposed to say no. 1, 2, 3. Okay, so take my word. The 3 minus h works its way in there. 1, because it's a different problem totally. And 2, there's the 3 minus h with the height right there of your slice. Okay? So, plug it in, you get the volume of the slice is equal to 10 times, oh, we got to work this out, sorry. 3 is to W, as 3 is to 3 minus h. And we need what? W, Hubert. Now my paper is an eraser, but I can't get this to be an eraser. Oh, now it's an eraser. Yesterday it wasn't an eraser. Yesterday when I did this it wrote. Oh well. 3W is equal to 3 times 3 minus h, and W is equal to what? 3 minus h? So 3 minus h and dH. Now what do we do with the volume? Multiply it by the what? Density, which is 62.5. And then the displacement, which is h. The height. This h goes all the way from here to here. Right there. Well, I'm trying to draw an arrowhead there. And there's h. So, let me take all this. And that's going to be mass is equal to 62.5 times 10 times 3 minus h times dH. Did I leave anything? And force is equal to the mass times the distance, which is h. So that's going to be 62.5 times 10 times 3 minus h times h dH. And now your integration work is going to be from, how tall is this thing? I mean, how much water is full, isn't it?
It's full.
So it's 3 meters or 3 feet, 0 to 3, 625 times 3h minus h squared dH. All right, finish her out.
What's the 62?
Density of water. Whoever asked that. I know it came from this area. And then I'm going to add something to it, and I want you to figure it in. But we'll do it after we get the answer. Because some of you may feel good after this problem, and my job is to make sure that you're what? discouraged. So I'm going to add something to it. And hopefully it'll discourage you into quitting. So I'm going to have a party at my house and watch the primary tonight. No, I'm just kidding.
Is it tonight?
Yep,
Where at? All
New Hampshire.
Oh, New Hampshire.
And then South Carolina's next.
They're voting today, is that right?
They're voting today, yeah.
Where are they gonna be at when they come here?
Everywhere.
No, I mean, Donald Trump, all of them, they going to
They're
drink?
going to different places, yeah.
Yeah, Trump's going to Clemson.
Yeah, Trump will be in Clemson, and he'll also be at the debate in Greenville Saturday. And I did get a no, but I've got contacts working on me some tickets, so.
Hey, you get me one, right?
Yeah, I'll
Hey,
get you
listen
one.
to this.
If I get some, I'll get you one.
I'll bring
Mama.
some cash Thursday.
What?
Mama told me the other day, she said that Bernie Sanders won't talk to her.
Oh, I love those robocalls. I answer every one of them.
No, she said it was actually like a
A
real
person?
person from their campaign that talked to her.
I had one call me from Cruz, and she was a woman, very nice lady. She says,
Oh, yeah.
I'm with Christians for Cruz. I said, well, I'm with Christians for Donald Trump. And she went, ooh. She had to think about that for a minute. She went, oh, so I'm assuming you're for Donald Trump. And she said, yes. And she said, well, let me ask you this. What if you wasn't voting for Donald Trump? Who you vote for? Ben Carson. Well, what if you was? Who would you vote for after Ben Carson? Fiorina. She says, I don't think you're going to vote for Cruz, are you? I said, with all due respect, ma'am, hell no. She said, why not? Because he's a politician, that's why. And he tells you what you want to hear. Goodbye, click. I didn't feel like listening to anything else. But I keep my phone charged, my home phone, because that's the ones they're going to call. And I keep it charged, and my son even answers them. My son will answer them. Huh? I don't get them on my cell phone. I wish I did, because I love answering them.
Old Bernie made a mistake calling me.
What'd you tell him? Did you give him what for?
No, she didn't say anything. She just said, well, he wasn't available right now to talk to you. So hopefully he'll call back later if he does.
So you asked to talk to the burn, huh?
Yeah.
The burn. Feel the burn. Although I would vote for him before I'd vote for Hillary. And a lot of people, he's a socialist. Yeah, but he ain't gonna win. Exactly. So I'll vote for him. He wants to what? Oh God. Yeah. Yeah, we really need that. Watch that video again. We really need legalization of marijuana. We need to be dumber. Yeah, we really need to be dumber. We got those people don't even know how. Don't even get me started on potheads. Oh, Jersey Shore, man, yeah. All right, so what did y'all get? Let's see. W is equal to 625, and that's going to be 3h squared over 2 minus h to the third over 3, evaluated at 0 and 3. I'll do 0 for y'all. And that would be 625. And 3 squared is 927 halves minus 27 thirds. W equals 625. 27 times 3.
27 over 6.
Thank you. Is this 27 over 6?
No, it ends up being 27.
This thing right here?
Yes, sir.
27 over 6. And W is equal to, well, 6 will go into 625 100 times. So 2,700, around 2,700. Well, let me put a dot here. Okay, 2,700 foot-pounds. What was the exact answer? 2812. Okay. Now, what am I going to add to it? Well, don't make it too difficult, okay? I don't need you to go in and try to figure out. All I want you to do is tell me if I changed, hold on a minute, if I put a spout up here, 2 foot higher. Okay, now one thing I don't want you to do, don't go in and try to figure the volume of this. You don't have to do that. Okay, this is an engineering problem. If you're going to do anything, are you going to undercompensate or are you going to overcompensate? You're going to overcompensate. So just think of it as a height. So what would the height be? Where would the height be different? Well, right, hold on, right here. What would it be? H plus 2. So figure that in. And the only reason I want you to figure it in, make another problem. Just go over to another page and draw this same trough but put a top on it and then make a note. The only difference in this and the previous problem is the height is h plus 2, or the displacement is h plus 2 versus h. Okay, so go over here and draw the same thing. And I'm going to draw a thing here that's 2 foot high. And this is 3 foot. And this is 3 foot. And this is 10 foot. And I just want you to make a note. Height is equal to h plus 2. This is really getting old. Gosh. This thing is nowhere near. So this problem would be 0 to 3. And then you'd have, I'm trying to think of the numbers that we've had. I can't remember all the numbers. 62.5 times h plus 2 times 3 minus h dh. This thing's writing all kind of crazy. I ain't even gonna write it. Is that what we had?
You put a 10 there, right? 62.5.
Okay, then we got to put a 10. Yeah. 625. So, what is wrong with this thing? Yeah. Hold on a second. Yeah, 625. So you got to use your FOIL method right here. Dang old algebra. 0 to 3. I don't know what's wrong with the board, so I'm just writing it up here. 625 comes out. Okay, so that's going to be 3h minus h squared plus 6 minus 2h. Y'all check me. And then, of course, combine like terms. 625, 0 to 3 of 3h minus 2h is h. So I'm going to say negative h squared minus h plus 6 dh. Is that what y'all got? All right, now do your integration. So that's going to be 625 and brackets negative h squared, h to the third over 3. Miss Anthony, you're not even paying attention. Hurting my feelings. Minus h squared over 2. Yeah, I did plus h, thank you. Plus 6h. Evaluated at 3. So 625, well, yeah, I know how to do this. I didn't even finish it, so we might as well finish it. 625. And that's going to be 1/3, negative 1/3, plus 1/2. No, that's not right, Hubert. I was thinking that was 1. I think that's about time to quit. All right, 27 over 3 is 9, right? And 9 divided by 2 is 4.5. And 18. So negative 4.5 plus 18, dang old 13.5. Somebody help me out. I'm sorry, I need a calculator. What does it come out to be? Or 4.5 is 22.5 minus 9. Doesn't that come out to be 13.5? And somebody multiply that out. Calculator drill team.
8437.
I'm sorry. 8437.
25.
That's good enough. Foot pounds. What do we come out with on the last one? That's all right. I don't want y'all to have to work.
2812.
Okay. So it's a little bit more work. A little bit more work. All righty. Make sure I didn't make a mistake because I don't have the answer. I didn't finish it. Now, what time's class over? 10, right? Good. We got 30 minutes. I want to do an inverted cylinder, which is basically called a tank.
I said do one more.
Do one more what?
One more of those inverted cylinders.
No, we're going to do a cylinder. We're going to do this one. Because I remember I'm trying to confuse you. I wonder if I could do this. I'm going to try to be innovative here. Y'all are going to be so impressed. Boom. Shut up. They're not. This is non-Euclidean geometry. Non-what? Just don't worry about it. Okay, now I'm going to mess it up because I don't have an arc, so. There we go. That's screwed up. I suck. Oops. Daggone. This thing's powerful when you don't want it to be. All right, there's your inverted cylinder. It's 12 feet long. Okay, just be quiet. This is a dang old. This is a gasoline tank underground, dang it. And a radius of 4 foot. And it's got gasoline in it. And the gasoline density is 42 pounds per cubic foot. I think so. Hold on, let me look. I didn't write down the. Hold on, let me look at the. Yes. It's full. And 42 pounds per cubic foot. That's gas, I think. I don't know. I didn't write down what it was. I'm just assuming it's gas. It may be OIL, but I don't think so because I think OIL is denser, like more dense. Yeah, OIL is not lighter than water, so that's probably gas. Pump it out, dang old hole, dang old right here. Now, I would suggest that you draw your little slither and draw a picture of it because you're going to have to think in terms of this slither. Because this guy right here, what is the width of this slither doing as it goes from here to here? It's changing, and you're going to have to think about that. There's your slither. You're going to have to use the Pythagorean theorem here because of this right here, this related rate. I think some of y'all might can see, dang old. Let's see if I can do this. I don't think it's going to let me draw that. No. Don't even have a right triangle on this dang thing. Everything's isosceles. So I'll have to draw it. Take my handy dandy. I'm going to draw it in magenta. Dang old Blue's Clues. Really? Thought I hit straight line. It's a conspiracy. Miss Anthony, I'm going to get you to come up here and work this thing. Why? Yeah. And then she'll be discouraged. There's your basic right triangle that's in there. And I'm going to go ahead and just tell you what to do. Where this is, I'm going to draw a circle. And I think it might be easier for you just to see it. So there's your circle on the end right here. And then you got a line, black line, coming right across. There. And I'm going to draw I'm just going to drop a line right here. And then if you connect this line with this line, there is where you see this right here. So this line up here, this whole line, this diameter is W.
What's that none over there?
What's that what?
None.
Gas.
Yeah.
Gas.
Really? Really? I mean, you can't see gas there?
Looks like non.
Petroleum product, okay? How's petroleum product? Is that good?
It looks like non-pound.
Okay. I'm glad y'all are not critical. I'm really glad y'all are not critical about my drawing up here. Mm-hmm, yeah.
That much faster they start the same thing.
All right, and I'm going to draw that, then I'm going to go down here and I'm going to put W over 2, which is the radius, squared, is equal to 4 squared minus h squared. Because you got to have something in there besides W. You can't have W in there. Well, this one right here. And this is technically H because it's moving. So let me take that out because that may be confusing you. There we go.
Now, why is it W over 2 again?
Because it's the, see, there's W right here.
Okay, I thought you meant the 2 was the radius. But
No, W
one
over
half-
2.
one half W
Yeah.
is the radius.
Yes, you can say 1/2 W. Now, just go with this because that's the way you're going to do it on an inverted cylinder.
So is the hypotenuse 4?
W, you solve this for W because that's what you need. Length times width times what? Height, Hubert. So here's your height, DH. Here's your length. I'll do that one for you. Your length is 12. So what do you need? Length times width times height. Well, yes, you need the width, which in this case is right there. You're right. I'm sorry. So W, if you know how to do this, 3 dots, that means you know how to do this. W is equal to 2 times the square root of 16 minus h squared. Basically, it's a manipulation of what? Pythagorean theorem. Ugh, that's nasty looking. So, what if your radius was 5? Then it'd be 2 times 25 minus h squared. You see what I'm saying? So you need to kind of not memorize this, but be very familiar with it when this thing's on its side.
Does it have to be less than the square root of 16 minus h squared, or can it be 2 times 4 minus 8?
It's 4 squared. 4 squared minus 8 squared. Is that what you're asking?
No, like,
What?
since you've got a perfect square minus a perfect square, if you're taking the square root of it, can it be 2 times 4 minus 8? Can you simplify it now?
No, because this is difference of 2 squares. This is 4 plus h, 4 minus h. Remember shortcut number 3?
Yeah.
You can't forget those shortcuts. You're thinking of taking 4, no, this right here is 2 times the square root of 4 plus h times what? 4 minus h. Right there. So you got to be careful there. Okay, so this is it. So you need to kind of put a red mark around this. And remember that if you have a radius of 2, then that's going to be 2 times 4 minus 8 squared. If you have a radius of 5, it'll be 25 minus 8 squared. If you have a radius of 7, it'll be 49 minus 8 squared. You with me? Unless you want to, get the whips and chains out and try to figure it out. Knock yourself out. All right, so now we've got the volume of the slice is equal to length times width times height. Now I want all of you to set your integral up now. So what's the diameter of this tank? 8. Good. That's full, so 0 to what? 0 to 8. See, man, be careful. Don't be speeding. So the volume of the slice is equal to, I'll do the length for you, 12, times 2 square root of 16 minus 8 squared times delta H. There's your volume. Now what we're going to do with that volume? Multiply by the density to get the what? The mass. Y'all starting to see a pattern? And what's the pattern? You're doing the same. Are you doing the same thing every time? Yes. What's the only difference between the conic, the trough, and the cylinder and the cylinder tank? What's the only difference? The related rate of your width or your radius or your whatever of the slither. That's the only difference. Every single one of these, you're doing the same methodology, doing the same thing each time, except this spot right here. Hold on, let me make this group. Well, what did I not group? I dadgum did the whole thing. Whatever. See, okay, if it's operator error, then why can I do this up here like that? Why can't I do it up here? If it's operator error, why can't I do it? Hold on a minute, I got to fix all this stuff. Y'all know this is a daggum conspiracy. I love that guy. Y'all know where that comes from, don't you? Dang old Shawshank Redemption. This is a conspiracy. Lord, it's a miracle. Man vanishes like a fart in the wind. Love that part. All right, y'all have no idea what I'm talking about. But anyway, this is this right here. This, let me take my handy dandy rectangle maker and color it magenta. This right here is the only thing that's different. The methodology on all of these are the same. So we take the mass, or find the mass is equal to volume times what? Density. The density is 42. Multiply that by 12 or 24. Let's go ahead and do 24 if y'all don't mind. 24. I'm waiting for somebody to say, where'd 24 come from? I don't know. 16 minus 8 squared. This is with the Civil War victory. DH. The Navy won the Civil War 42 times 24, blah, blah, blah. Now what? No. You gotta, dang old 8 minus h. What is 8 minus h? The height. All right, so do that. 8 minus h. That's going to be mass times your distance. Dang old force. So 42 times 24. Well, 42 times 20 is 840. 840, 164, 964. Somebody check my math. I suck. I must have messed that up big time. 1008. Square root of 16 minus h squared times h, or 8 minus h. Let's see, it is 8 feet tall, right? 8 minus h dh. And now you can set up your integral, which will be from 0 to 8. Now, you're doing something here you ain't done before. And what is that? What's the problem? You're supposed to look at this and go, I don't know what to do. Well, F is equal to, I'm going to rewrite it, maybe that'll help you. 1008. What did I tell my calc class? My calc 1 class. What did I tell you about radicals? Quit when you see them. Good job. They don't play well with who? With calculus. Remember? Calculus and radicals don't what? So 16 minus h squared raised to the what? Good. Because you got to distribute that nasty looking thing. Times, you got to distribute it with 8 minus h. Or, Mr. Brooks, what do? Quit. This is where you put cannot be done. That's what you do. Or you erase the radical and put parentheses around it. Then you can do it. How do I know that? I used to do stuff like that. All right. So I've got to take this. I'm not worried about the 1008 because that's going to come outside. So I've got to distribute this guy with these two guys. To do that. So 8 times blah, blah, blah minus h times blah, blah, blah. Or you can leave it with the radical if you want to, but you're going to get a mess.
Can you not go ahead and go to 16 and the
This is 4 plus h, 4 minus h. Basically, you're going to get F, or work, is equal to 0 to 8 and 1008 of 8 times 16 minus h squared to the 1/2 power minus, let's see, that's a minus symbol, so minus h times 16 minus h squared, running out of room, to the 1/2 power dh. And let's stop right there, because we're going to get a arc sine in there somewhere. I can see that, and I'm going to have to explain that to you. So let's stop right there. And I will, right quick, cut all the recording off and